In this tutorial we are going to go through how to create objects manually. The first thing we will do is to start creating some random variable objects. So I'm going to this objects pane. I'm double clicking to expand this branch. I'm going to random variable, and there are continuous random variables. You'll see that there's a inheritance pattern here, namely that a random variable is inherited from a parameter, and a continuous random variable is of course inherited from the random variable and from the parameter. You right click with your mouse and press create, and there you go, an object has been created. In this case we're going to call it random variable number 1. We are going to choose a distribution for it, so I double click and get the available distribution. In this distributions, in this case the log normal is the one I want to choose. I want to give it a mean equals 500, and I want to give it a standard deviation equal to 100. And if you look further down, I'm going to scroll a little bit, look further down, the parameters of the log normal distribution have now been automatically computed. You could also give the parameter values, and in that case the mean standard deviation would be automatically computed. Let me create a couple of more random variables. Create and create. This one here I'm going to call random variable 2. I want it to be a log normal distribution. I want it to have a mean equals to 2000, and I want it to have a standard deviation equals 400. And the last random variable, I'm going to give the name random variable 3 or RV3, and that's going to be also a log normal distribution. I want it to have a mean equals 5 and a standard deviation equals to 0.5. Those are my random variables. Now I'm going to go ahead and create a function. So let me collapse the parameter branch and click on the function. There are no subclasses out of function, so I'm simply going to create one. I'm going to call it my limit state function. The expression I can enter by double clicking in the expression field, and I'm going to write 1 minus, and here you can, it's fairly free in terms of syntax, you can add spaces as you wish here. So here I have 1 minus. I want to have random variable number 2 divided by 1000 times random variable number 3, and then in the next term I want to have random variable number 1. Let me put a parenthesis. I'm gonna have this whole term squared, so let me start with a parenthesis and have random variable number 1 divided by 200 times random variable number 3, and that whole term to the power of 2. You could use other mathematical functions, to square root, sine, cosine, and so forth also, but this is what we're going to stick with in this example. That's my domain. I have my random variables and I have my limit state function. In terms of the other parameters here, you might guess that this one here tells you that it's a finite difference scheme that's going to be used to compute the gradients or the derivatives of this function with a perturbation factor of 1,000th of the standard deviation of the random variable. Going to the analysis now, we need to create some analysis tools. I double click here to see I have just one option for to solve the constrained optimization problem that is involved in form analysis. So I'm going to create one. I'm going to call it my stepper solver. I'm going to just accept the sort of the maximum number of iterations and the start point. I could change those, but when it comes to the step size searcher and a number of these other tools here, I just don't have them created yet, so I need to go down and create them before I can give them to this stepper who's going to need to use them all. So in terms of step size searcher, there's our major rule or the fixed step size. In this case I'm going to take a chance and hope that the fixed step size will solve the problem. So this is my step size searcher. I'm going to accept the standard step size there. I go to the direction searcher. I only have one option here also. I create that and I give it a name called my direction searcher. I go to the merit function checker. Here I have one option also available. So this is, I'm going to call my merit checker, and I'm going to accept the standard parameters given here. You can also change them if you have the knowledge and the interest of doing so. Going to the transformer, and there's a no correlation transformer available at this particular time. I'm going to call that my transformer. And you can see now the output. We talked about this in an earlier tutorial, that you may want to change the output level to avoid slowing down the analysis. That we're going to leave for now and go to the convergence checker. I'm going to give it the following name, my convergence checker. And often you have a number of these tools available and you play around with them and you change them to check various things in your analysis. The next thing we're now creating is a random number generator. And that's going to need a transformer. So here I need to give it the transformer that I gave. So double click, click out here to get the options that are available already. It recognized that I already had created a transformer, so that's one I'm going to use. And in terms of accumulators, I have a couple of options. It's the histogram I'm going to focus on right now, and I'm going to call it my histogram accumulator. And in this particular case, we're not going to bother giving it an output file. We're just interested in the screen output. Let me now go back to my solver and give it these various tools that I now have created. So in each one I double click and then I get a little list of the options available. I've just created these tools right now, so it recognizes, RT recognizes that they are there. And that should complete my task, and I've set up now the analysis tools and as well as random variables and the functions. And I go to analysis, I run a sampling analysis, histogram type with the limit state function. It proposes one of the functions available. In fact, this is the only one at this time. I press OK, and there the analysis is running. So this was a tutorial showing how to create those tools manually. If you're interested, you can of course go to File and save to save these objects that you created as an input file that you can load later on.